Irodov problem number 1.238. Find the moment of inertia of a thin uniform rod relative to the axis which is perpendicular to the rod and passes through its end if the mass of the rod is m and its length L. And part B of a thin uniform rectangular plate relative to the axis passing perpendicular to the plane of the plate through one of its vertices if the sides of the plate are equal to A and B and its mass is m. So for part A, we have a thin rod of length L and mass is given as small m, and we have to find the moment of inertia about this axis which passes through one of its ends. Okay. We will use integration to solve this. Let's say at a distance x, we take a small element dx. Okay. And mass of this small element is dm. Okay. So we know the moment of inertia of a small mass or a point mass m at a distance x from an axis is dm x square. Okay. Now dm we can further simplify as the mass of the rod is m, so mass per unit length is m by L, and for a small length dx it will be m by L times dx. So let's just replace the dm in terms of this. So that will be m by L times dx times x square. Okay. Or we can further simplify this or rearrange it and say m by L x square dx. Now to find the moment of inertia of the entire length of the rod, we vary x from 0 to L and integrate over the entire length of the rod. So I will be integral x varies from 0 to L m by L x square dx. M by L is a constant, we take it out. X squared dx integration is x cubed by 3, and the limits we put as 0 to L. So this becomes m L cube by 3L. L we can cancel one of the L's, so I becomes 1/3 m L square. Okay, so that is our answer for part A. So for part B, we have a rectangular plate like this. Let's say this side is A and this side is B. Okay. Now the axis is passing through one of the vertices. So let's say this is the axis. It passes through one of the vertices. We have to find the eye of this laminar rectangular plate about that axis. Okay. How do we do this? We know this would be our center of mass of this laminar plane. Why am I interested in the center of mass is I want to use the parallel axis theorem, and the parallel axis theorem says if we know the moment of inertia about an axis that passes through the center of mass. Let's say we have this axis passing through the center of mass. Okay. If we know IC, then we can find the moment of inertia about another axis which is parallel to that axis about which we know the moment of inertia. We can find that how? We can find I, whatever this axis is, let's say IA is IC plus the distance between those two parallel axes. If we know, let's say that distance is r, then it will be mass of the lamina m times r square. Okay, so that is parallel axis theorem. So I just rewrote that nicely. So r is the distance between those two parallel axes. One of the axes has to pass through the center of mass and the other axis has to be parallel to that axis. Okay. Now, do we know the I of a laminar rectangle about its center of axis? Yes, we know that, but maybe I should show you how to derive it, okay, using this result maybe. Okay. So let's look at that. So let's say we take at a distance x from the center of mass, we take a small element, okay, a small element of width dx. Okay. So this is almost like a thin rod, okay, of length a, right? Let's consider another axis that is passing through the center. Lot of axes here. Let's call that axis B. And then let's also consider, just because I want to use this and show you a few things, let's also consider another axis that is passing through the end point. Let's call that axis C. Okay. Now let's do some magic. IC of a rod of length A. Actually, I should write this as, maybe I should write this as D, so I don't confuse with this one, okay? Okay, so we just calculated ID, I will write it as DI because we are considering a small element, okay? So a small moment of inertia about this axis D of this element will be equals to what? We got that expression 1/3 ml square, so dm in our case, and a square. Okay. Now, if I calculate the moment of inertia about axis B, so dIB, what I will do is I will add this distance, which is a by 2, dm a by 2 square should be equal to what we got here, dID. Again, we are basically using the parallel axis theorem. So dIB we get as dID, which is 1/3 dm a square minus dm a square by 4. or we can write this as 2L 1 by 12 dm a square. So we got the moment of inertia of this element about axis B. Okay, great. This is actually a known expression, moment of inertia of a rod about an axis that is passing through its center of mass is 112 m a square, where a is the length of the rod. But I arrived at this using this expression. Okay. Now, so we found out dIB. So this was about this element center of mass. So dIB, if I add dm times x square, we will get the moment of inertia around about this axis C. Okay. So DIC then becomes 1 by 12 dm a square plus dm x square. Okay. Now I should do another step here, which is to find the value of dm. Now dm, the total mass is m, the area of this plate is AB, and the area of this element is A times dx. So AA gets cancelled, so this becomes m by B dx. So DIC we can write as 1 by 12 m by B a square dx plus m by B x square dx. Okay. Now, if I want to calculate the moment of inertia of this entire plate about C, I just integrate this. What would be my range of x will be minus b by 2 to plus b by 2. So this becomes, let's say, m a square by 12b integral dx minus b by 2 to b by 2, and this becomes m by b integral x square dx minus b by 2 to b by 2. Let's quickly evaluate this. So m a square by 12b, so b by 2 minus b by 2, so plus b, plus m by b x cube by 3, right? So that becomes b cube by 8 minus b cube by 8, so it becomes b cube by 4. Okay. So b gets cancelled here, b and b square. So this becomes m a square by 12 plus m b square by 4. Oh, actually no, we had x cube by 3, so this should be into 3, which is, it should be by 12. So it came out to be 1 by 12 m a square plus b square. Okay. Again, this is a known result, but I just did the derivation. So we know for a plate of side A and B, if we calculate the moment of inertia about an axis which is passing through the center and perpendicular to the plane of the plate, it is 1/12 m a square plus b square. Okay. Now that's not the end of the story, because we really need to find the I about this axis. How can we find that? Now we know this, so we can again use parallel axis theorem. This plus the distance between these two axes, which is r. Okay. Now how much would be r? So if I draw a perpendicular here, so this distance is b by 2 and this distance is a by 2. So the r distance will be a square plus b square root. So let me just write that. So IC plus mr square. Okay. IC we have 1/12 m a square plus b square, and mr square we will have m. R square will be a square plus b square divided by 4. So the net I about the axis, it will be 4 by 12, so 1/3. B squared. So this is my solution. Okay.